Hi everyone, today we're going to work on solving real-world ratio and rate problems. So before we get started, please make sure that you have your note sheet loaded into GoodNotes, and then you can go ahead and fill out this note sheet as we go along with the video. Let's get started. We're going to start by solving some ratio problems. So when we solve ratio problems, you can use either a bar diagram or equivalent fractions. So let's go ahead and write that down. We can use a bar diagram or equivalent fractions. Now, I think the way that you're going to find works best is using equivalent fractions. However, everybody's mind works a little bit differently, so I do want to show you both methods right now. So let's try number 1. Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So the first thing that we're going to do with our bar diagram is get the information down that we know. So we know that there are a total of 150 students. I'm going to write that at the top. 150 students. Now, the next thing I know is that 2 out of 3 students in the class prefer the gel toothpaste. So what I'm going to do next is split this bar into 3 sections. Okay? Now, I'm just estimating, but these are supposed to represent exactly equal sections of the 150 students. So we know that 2 out of these 3 sections, so this part and this part right here, would be the students who prefer the gel toothpaste. And over here, this section is going to be those who do not prefer gel. Let's just say not gel. All right, so what we need to do then is figure out how do we split this 150 students into 3 equal groups. So what I'm going to do is use division. We're going to see how many times does 3 go into 150. Well, we know that 3 goes into 15 5 times. 3 times 5 is 15. We can subtract, bring down our 0, and we get 50. So what that means is that each of these sections would have to be 50 students. Now let's go back to our question. It says, use this ratio to predict how many students in the entire middle school prefer gel. Well, we know that those who prefer gel would be in this section. So that group right there has there's 2 groups of 50. So what we're going to do is add 50 plus 50, which of course gives us 100. So 100 students, we would predict, prefer the gel toothpaste. 100 students prefer gel. Okay? Now let's look at how we can use equivalent fractions to solve the same problem and again get the same answer. We have now seen using the bar diagram that our answer should be 100 students, but now I want to show you how we can use equivalent fractions for that. Now, the key thing to remember when we're writing fractions is that we know what our numerators and our denominators represent. So the way I want to write this fraction is the number of students who like gel over our total. Okay? And if we go back to our problem, it said the ratio of 2 out of the 3 students in Mrs. Mason's class prefer the gel toothpaste. So I'm going to go ahead and use that information first. The ratio was, was 2 students liked gel to every 3 students total. When we use equivalent fractions now, we're going to set this equal to another fraction. And our total is going to be 150 because the problem said that Heritage Middle School has 150 students, so that's our total. The part that we don't know is out of those 150, how many of them would like gel? So what we need to do is figure out, well, what can I do mathematically that would get me from 3 to 150? Well, if you don't know that, we're trying to figure out something we could multiply. So the opposite of multiplying is dividing. And so what I'm going to do again is figure out how many times does 3 go into 150, which we actually did before. We found out that that gives us 50. And what that means is to get from the number 3 to 150, we need to multiply by 50. Because we're trying to create equivalent or equal fractions, we need to do the same thing to the numerator. So here we're going to have to multiply by 50 as well. That's the only way that we can keep those fractions the same, is if we perform the same mathematical operation to both the numerator and the denominator. So let's go ahead and see 50 times 2. Of course we get 100 again. And when we look at how we set this up, our numerator indicated the number of students that would like the gel. So again, our answer here would be 100 students prefer gel. Okay, if you need to pause the video, go ahead and do that, and then get ready to write down our notes for our second problem. Okay, let's go ahead and try example 2. The ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 text messages. How many text messages did his sister send? So we're going to, again, try using a bar diagram to help us solve this problem first. So what I'm going to do is take the information that I know. So the first thing I know is that our ratio here is going to be 3 to 4. So if I can section this off, maybe I should make it more like this. Here we go. 1, 2, 3. This part right here is going to represent Lucas. He has 3 sections. Go ahead and erase that. And we know that his sister needs 4 sections. Okay, now again, my drawing is not perfect. Each of these sections is supposed to be equal. Okay, so this right here, those are 4 sections, and this is for his sister. Okay, and again, the reason we did this is because the ratio given in our problem, it said the text messages sent by Lucas compared to his sister was 3 to 4. So again, Lucas is going to need 3 sections, which are these 3 right here, and his sister is going to need 4 sections, which is this part right here. Okay, now the other piece of information that we know is that Lucas sent 18 text messages. So again, we're just focusing on Lucas's area right here, these 3 sections, which is a total of 18 texts. So what we need to do now is figure out if Lucas has 3 of these sections that represent the 18 texts, how many texts need to be included in each section of our bar graph or our bar diagram. So we're going to divide 3 into 18. Hopefully you guys all know that 3 goes into 18 6 times. So what that means is that each of these boxes should be equal to 6. Okay. So Lucas sent 18 texts. We can split that 18 into 3 groups of 6. Since the ratio was 3 to 4, his sister had 4 groups. So to figure out the total number of text messages that his sister had, we're going to have to multiply 6 times 4, which of course is 24. That means that his sister sent 24 text messages. Okay? Now let's go ahead and solve that same problem, again where we know the answer is going to be 24 text messages, but let's use equivalent fractions to solve it. Okay? Again, the important thing when we use equivalent fractions is to make sure we know what our numerator represents and what our denominator represents. So the way I'm going to set this one up is Lucas is going to be our numerator, and his sister is going to be the denominator. Okay, and it told us in the problem that the ratio is 3 to 4, so that's how I'm going to start. And now we're going to set another fraction equal to this. Now, the information we were given in the problem, if we look up again, it says that Lucas sent 18 text messages. So Lucas, we said, is our numerator. So since he sent 18 text messages, that's going to be our numerator. And the number of text messages his sister sent is our denominator, which is what we don't know. Okay, I'm just going to put a question mark for now. Of course, you could use a variable such as x to indicate that you don't know what that's going to be. So now we have to figure out, well, how can we get from 3 to 18? Well, we know that 3 times 6 is 18, right? So if 3 times 6 is 18, to create an equivalent or equal fraction, we have to do the same thing to the denominator. So we're going to go ahead and multiply this by 6 as well. 4 times 6 is 24. So our answer here, his sister sent 24 text messages. Next, we're going to go ahead and try some rate problems. If you need to finish up your notes here, please feel free to pause the video. Make sure you get all of this information in your notes so you have something tangible and good to look back on later. Okay, so when we solve rate problems, it's best to start by finding the unit rate. You guys have already learned about the unit rate earlier in this unit. And if you recall, the unit rate means how much is it for 1, okay? That's kind of the way I always think about it in my head, is the unit rate is how much for 1. So that's going to be a key idea in solving some of these rate problems. So if you are still struggling with the idea of unit rate, you probably want to go back and review that before you move on with solving some of these real world problems related to rate, because again, it's a really important idea here. All right, our first example says that Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? And at what rate did he drive his motorcycle? So as I just mentioned, the first thing that we're going to want to do is find our unit rate. What we know so far is that he drove 120 miles in 3 hours. Okay, and finding the unit rate means how much for 1. So in this case, we're dealing with hours. So how many miles did he drive the motorcycle in 1 hour? So again, what we can do is we can divide 120 by 3, or when we think of thinking back to equivalent fractions, which is what we just did, to get from 3 to 1, we need to divide this by 3. Okay? Whatever we do in the numerator, or in the denominator, we're going to have to do in the numerator. So we're going to have to divide that by 3 as well. So let's take it off to the side here and figure out how many times 3 goes into 120. Well, 3 goes into 12 4 times. And of course, we need to include our 0. So here we would get 40 miles. Again, our units stay the same in equivalent fractions. All right, so we have 40 miles there. Our unit rate means that Jeremy is able to drive 40 miles in 1 hour. Okay, the next thing that we're going to need to do is, after we find that unit rate, we're going to have to multiply. And we have to go back to the problem to see what we're going to have to multiply by. So again, let's read what it says. He drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? So if we know he can drive 40 miles in 1 hour, we're going to have to take that 40 miles and multiply it by 5 hours. Okay, we can set up our multiplication problem. 40 times 5 is going to be 200. Okay? And finally, just like any word problem that we would do, we need to make sure that we clearly have answered our question. So our final answer is that Jeremy, Jeremy, can drive 200 miles in 5 hours, driving at a rate of 40 miles per hour. So he's able to drive 200 miles in 5 hours if he's going 40 miles per hour. Okay, let's try one more problem, and then I will let you guys go and practice this concept and get some more practice with additional problems. Okay, here's our next rate example. Julie spent $28 on 2 DVDs. At this rate, how much would 5 DVDs cost? And at what rate did she spend her money? So the first thing again that we're going to do is to find the unit rate. The unit rate means how much is it for 1 DVD. So we're going to set this up, $28 divided by 2 DVDs. Okay, you can go ahead and just divide, but I want to show you using equivalent fractions as we've done in the past, because what we're trying to do is figure out how much is it for 1 DVD. Well, of course, to get from 2 to 1, mathematically, we're going to need to divide by 2. So we're going to be doing the same thing here. Okay, 28 divided by 2. Let's do the math off to the side. 2 goes into 2 once. Bring down our 8, and 2 goes into 8 4 times. So we're left here with $14. Okay, and what that means is our unit rate is $14 per 1 DVD. So 1 DVD costs $14. But the problem is asking us, at this rate, at $14 per DVD, how much would 5 cost? So then what we need to do is take our $14 and multiply it by 5 DVDs. Okay, so let's go ahead and show our work over here. 4 times 5 is 20. 5 times 1 is 5, plus 2 is 7. So here we would get 70. Okay, so again, this equals 70. And finally, we want to make sure our answer is very clear. So the way that we would write our final answer is that Julie would spend $70 on 5 DVDs at a rate, which in this case again means like the price of $14 per DVD. Okay. So again, when we're solving our rate problems, the first thing we're going to do is find our unit rate, in other words, how much for 1, and then we're going to multiply that by whatever the number is given in the problem. Okay, and again, anytime we're doing any word problems, we need to make sure that we're clearly answering every question that's asked in the problem. And we also want to make sure that it makes sense. So in this case, we got an answer of $70 on 5 DVDs. Well, that sure makes sense if we know that each DVD was about $14. This seems like a reasonable answer. Okay, I hope that helped, and now you are ready to go ahead and complete the note check, and then you can also move on to the next step to practice additional problems. Please make sure that you ask your teacher if you have any questions.